The application of Newton's third law in towing car.
Table of content for our presentation is About Us, Introduction, Problem Statement, Problem Solution, Conclusion, and References.
About Us program code CDCS 143, course groups JCDCS 14340D, course code MAT272. Our leader Harika Zuri binti Ruzaidi 2022814766. Next, Muhammad Aiman bin Azhar 2022677038, and myself Faiza Udina binti Muhammad Fauzi 2022699196.
Isaac Newton was an influential scientist. He played a big role in the mathematics and physics subject. There are many formulas that he invented, but these three laws of motion are the famous among them. Newton's first law, or we call it inertia, it says that objects that are at rest will remain at rest. An object moving at a uniform rate in a straight line will continue to be in motion unless there is an external force acting on it. As you can see from the example, the object stays in its position until the car stops. Newton's second law. The law states an object will accelerate if a force is applied to it. This law specifies that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. The more force applies to an object, the higher the acceleration will be generated. The formula is F equal to ma. F force, m mass, and a acceleration. As you can see, man push the object and generate acceleration, but after give more force, the acceleration increase and the speed also increase. Lastly is Newton's third law. The law says for each action of an object will have action force and reaction force, which is equal in magnitude but acting in the opposite direction. We can use this law to know the normal and reaction force for an object, the minimum force to move it, acceleration, and tension on the string. Newton's third law will help us to know the interaction between objects and being useful in solving problems that involving force in mechanics. As you can see from the example, the force man push to the box are equal with the force box push the man. Another example is a horse pull a cart, a car moving on the road, and a bullet fire from a gun.
Next is the problem statement. Given a car towing another car, a 2-ton Hilux pulls a 0.75-ton console on a flat road, gradually increasing its speed to 20 meters per second in 25 seconds. The combined resistance of the Hilux and console, which are proportional to their masses, sum up to 1000 Newton. From the statement, this is what the image will look like. K is for console, H is Hilux, P is tension, F is force, and A is acceleration. From the statement, there will be 4 follow-up questions. The first one is, find the acceleration. With acceleration, we need to use the velocity over time. So from the question, we can get 20 over 25, and it will equal to 0.8 meter per second. The next question is, find the driving force exerted by the engine, which is F. So we need to sum up both masses of console and Hilux, which is 3,750, and we will use the formula of F equals to ma, which is F minus 1000 equals to 3,750 times 0.8, and we will get F equals to 4,000 Newton. The third question is, find the friction of each car. By using ratio of mass, we can conclude that the ratio of console and Hilux is 1 to 4. So So we can use the sum of friction, and we will get the friction of conch-shell is 200 and for hylax is 800. Last but not least, the fourth question is find the tension in the tow bar. So for this question, we can use two methods, which is by using conch-shell or by using hylax. So first, I'll be explaining the conch-shell, which we can use the formula of F equals to MA, and we will get T minus FC equals to 750 times 0.8, and we can substitute the FC to 200, and we will get T equals to 800 Newton. And next one is for hylax. We can also use F equals to MA, but we will get 4000 minus T plus FC equals to 3000 times 0.8. And the same as before, we can substitute the FC to 800, which we got from the last question, and T will equals to 800 Newton.
Conclusion: every action has an equal and opposite reaction according to Newton's third law of motion. This statement implies that two interacting things are always subject to a pair of forces. Based on the discussion, physics is not only restricted to be applied to technology, but we can also apply it to solve our problems, also in emergency cases. Once we identify the physical involved in the problem, we can create a good solution.